Back. We've got a couple more to put into your electronic notebook. We're going to talk about angle pairs and parallel lines again. Got 3 more theorems to discuss with you. Alternate interior angles. This is interesting because when you have parallel lines cut by transversal, your alternate interior angles are going to be equal. Same thing's true for your alternate exterior angles. They're going to be equal. Now your same side, they're not equal, but they're supplementary, which means they add up and they will together, the sum of them will equal 180 degrees. So alternate interior, alternate exterior, and corresponding angles, which we just learned in the previous example, all those angles equal each other, okay? Same side or supplementary. Same side interior supplementary. Okay. So let's look at example 2. They want us to find some more angle measures using one of these theorems up above, okay? So let's take a look. Find the measure of angle EDF. So this little angle right here is what they're after. You can see that lines ED and BC are parallel. They've got them marked with that little arrowhead indicating that they are indeed parallel. We need to know that ahead of time so we can apply this theorem. This theorem does not apply unless the lines are parallel. If they're not parallel, then no dice, okay? All right, so this is what you have to decide is what is the relationship between angles EDF and the 125 degrees that you see up here. Is there a relationship? More than likely there is. It's an odd thing to not have a relationship, but more than likely it is. There's a couple ways to get around this, and I'm going to show you one way to do it. They appear to be both on the outside of the 2 lines, on the opposite sides of transversal. They appear to be alternate exterior angles, just the way that it's written right away. What do we know about alternate exterior angles? Yes, they are congruent. So that means that if that top angle ABC is 125 degrees, then EDF, which is the alternate exterior angle to it, must also be 125 degrees. That is not the only way to find that answer, but it is a way to do it, okay? Let's take a look at the measure of angle TUS. TUS. So they're asking us to find the measure of this angle right here, 23x degrees. Now, we see that lines RS and TU are parallel. They showed us the parallel signs. And the only thing we know is RSU is 13x degrees and TUS is 23x degrees. That's all we know. The other thing, we have to look at them positionally. They're both interior and on the same side of the transversal. So that means they're same side interior angles. And according to the theorem, they are supplementary. So we're going to take our 13x degrees, we're going to add our 23x degrees, and together that's going to equal 180 degrees. Okay, so let's solve this. Got to add 23 and 13. Looks like that's 36x is equal to 180. Divide each side by 36. This might be a good time to get a calculator to figure out what 180 divided by 36 is. That would be 5. Now that is not, the angle is not 5 degrees. That's just what x is. To find out the actual measure of TUS, you have to take the angle measure, which is 23x degrees, and plug in the 5 for the x. 23 times 5 is going to end up being 115, I think. Okay. I don't have my calculator right in front of me, but that seems right. So it's 115 degrees. That's what they're asking us to find. Now, sometimes they'll say find x, which is great, but pay attention. What are they asking you to find, and make sure you are answering the question. All right, using your above three theorems, see if you can do the check it out and figure out the measure of angle ABD. See if you can figure that out. If you have any questions, bring those to class.